In this lecture, we are going to discuss about unicasting, multicasting, and broadcasting networking concepts. So, before starting the lecture, the detailed representation of all protocols in all the three ways. First, we will discuss about a brief intro about what is unicasting and what is multicast and what is multiple unicast and broadcasting. So when we want to transfer any message to any of the receiver, we can use any of the following ways through the routing. It may be a unicasting or multicasting or broadcasting. Later we will discuss about the difference between multicasting and multiple unicasting. So these ways we are going to discuss in detail one by one. So this is a scenario happens between source and the destination. S represents for source and D represents the destination, where we do the unicasting of data transfer. So see here, the for each and every router, when we pass any message to the router will forward the message to one of its interfaces. So interfaces are nothing but the connectivities related with the router. So in this case, for each and every router, if there is any incoming packets and it will be passed to any of the three interfaces, those three interfaces may be an outgoing interfaces, and it will forward the messages to only one path, that is a one interface. So out of all interfaces, only one interface is chosen in order to forward the message, that is called as unicasting. So finally, through all routers, any one of the interfaces will be chosen, and through that the data will be transferred to the destination finally. So in unicasting, the router forwards the received packet through only one of its interfaces, though it has many interfaces. So next we go for multicasting. So see here, there are different set of nodes connected here, and S represents the source, and G1, G2, G3. So multiple set of groups are there. So multicasting is a representation of forwarding a message to a specific groups. So the nodes that comes under the same group will get the message. So for example, all these nodes are represented with the G1 that belongs to the group 1. So when I want to forward a message, the destination address will be the group address through which the data will be forwarded. So in multicasting, it identifies wherever the group nodes are available, the networking packets will be forwarded through all the interfaces through which it reaches the group casted nodes. So in multicasting, specifically the router forwards the received packet through several of its interfaces, because we cannot finalize only one interface to forward the data, because multiple nodes belongs to the same group. So in order to reach all the nodes that belongs to the same group, we need to identify with the interfaces which are all needed that represents the data to forward through all the group nodes. So multicasting will not restrict to one of the interfaces. It can take multiple interfaces to pass the messages. And multicasting versus multiple unicasting. So there is a difference between multicasting and multiple unicasting. In multiple unicasting, multicasting, the data will be forwarded to all the nodes that belongs to the same group. So see for the second slide, second image, that is multiple unicasting. The source will forward the data and there are multiple nodes available. So each and every time the node will forward the data, the router will forward the data packets to any of the destinations specified. So whichever node is having their destination address in the packet will receive the data. So these nodes are called as, these type of data transfer is called as multiple unicasting. So emulation of multicasting through multiple unicasting is not efficient, because when we want to forward a message package, forward a data to a larger set of groups, usually we need to create all the nodes into a specific group, and all nodes will get the data packet through multicasting. But we cannot reach this with the help of multiple unicasting. So few of the multicasting applications are access to distributed databases, information dissemination, dissemination of news. So when we forward any news, it will be forwarded to a specific groups, similar to the WhatsApp groups what we are creating. So teleconferencing, distance learning. So only the specific users that are related for the particular message will get the data. So we are not forwarding the message to everyone that are connected to the network. So when we discuss about the multicasting, so multicasting, there are several set of protocols available. So first, in this lecture, whatever the discussions we have done with all the three types of routing, few protocols are related with the multicasting. So the basic concepts behind those protocols we will see now. So in unicasting, each router in the domain has a table. So each and every router maintains its routing table. And in this routing table, the shortest path to reach the destination will be available. So the routing table will be updated by the router for each and every time. So whenever there is any node failure happens, based upon the node failure, if any other route path has been selected, the routing table will be updated. So now we discuss about the shortest path structure for unicast routing. Unicast is nothing but the router will forward the message whichever it receives through only one of its interfaces. So only one interface will be chosen. So here a routing table of R1 is specified and the destination nodes. So which are all the nodes we are going to forward the packets will be represented. N1, N2, N3, N4 and N5 and N6. So the next hop we are going to identify through which router the packet will be forwarded to the destination. So when we take for router 1, it reaches for N1, N is a node, it may be a system that is connected here, and to reach N1 there is no interface needed because this is directly connected to this router. Similarly for N5, this is also directly connected on the other side with the router. And when we go for N2, N3 and N4, so all these N2, N3, N4 are all on the one side of the router. It can be reached through the router 2. So the nearest router for R1 will be R2, through which only the data will be forwarded and reach the destinations of N2, N3 and N4. Similarly, on other side, if I want to reach the node N6, the router will forward the data through the router R4. R4 will be the next hop through which the data will be forwarded and reach the destination N6. So each router will maintain a table like this, specifies all the destinations and which is the next hop, and this representation is the shortest path through which the nodes will forward the data packet through the router, and the router will forward through one of its interfaces and reaches the destination. So when we go for multicast routing, each involved router needs to construct the shortest path for each group. So previously there is no group available. So it identifies the destination and create the shortest path. Now it creates the shortest path for each and every group. So we will see two different ways for this. First, the source based tree approach. Each router needs to have only one shortest path for each group. So the same scenario, but here the nodes are not represented, but the groups are represented. These nodes, the black colors are the nodes that is available in G1 as well as G2. That's nothing but it is in group 1 as well as in group 2. So now we construct a routing table for R1. R1 destinations are specific to groups, not to a specific nodes in the network. So to reach group 1, group 2, group 3, group 4 and group 5, what are all the next hops that are represented in the routing table? So for group 1, for example, if you take R1, it needs to reach group 1. There are few nodes that are available in group 1. So identify the next hop routers through which the data will be forwarded to the group 1 nodes. So what are all nodes we have in group 1? Through which router it reaches the destination, that has to be the next hop. So for group 1, immediate group 1 node is also there. So it is that is a immediate one. Then another group 1 will be there that can be reached through R2 router. Another group 1 node will be there that can be reached through R3 router. So specify what are all routers, that is the intermediate routers through which the data will be forwarded and reaches all the nodes of group 1. Similarly for group 2, group 3, group 4 and group 5. So this is for source based tree approach. So for each and every group, what are all the source nodes connected with it? For all the source node, which are all the routers, that is the next interfaces through which it is connected, that will be the next one. The next type of group-based approach is a group shared tree approach, where we are going to represent a core router, and this core router is directly connected with a few of the nodes, and the routing table will be specifically for core router. So we are connecting all the nodes through by which the core router will pass the data. So core router table we are going to discuss now. This router is for specifically for the group shared data. So destination nodes, all the group nodes are there, and from the core router, few of the groups are directly connected, and few of the groups nodes are not directly connected. So whichever is directly connected, it can easily forward, and which are all the nodes from different groups or not directly with the core router, it will choose the nearest next form through which it will forward the data. Is that clear? So G1 is directly connected with the cow router, and if you take for this cow router G1, another nodes are also there. These nodes are reached by R2 as well as R3 router as well as R4. So this is a representation where we can depend on multiple routers to reach all the nodes, but a special core router will be there, and this core router will connect to the nodes directly, so that path, that next hop, that the cost will be reduced. So group shared approach, if you forward a data to the core router, it will automatically updates its table, and all the nodes that are connected to that core router will directly get the data, and other nodes from other groups will get the data through the next hop. So in the group shared tree approach, only core router which has a shortest path for each group that is involved for multicasting. So in previous cases, all the routers will have the shortest path, but in core router concept, it maintains the shortest path and it will do the multicasting of packets. So all these are the basics of unicasting and multicasting approaches, how it differs from one another. Thank you.